let's try to log the generated request struct so we can make sure that everything works. To do that, we can use the debug macro and we can pass the request to it. Now the compiler will complain because request does not implement the debug trait. And if we go to the request, we have already implemented the debug trait for the error type, but it will be quite cumbersome to implement debug for all of our types, because we'll need to be able to log the request and to log the query string and the method, and the query string contains the value. So we have to implement debug on all of these types so that we can log the request to the console. To save us this work, the Rust compiler can actually provide basic implementation for some traits, and the debug trait is one of those. To do that, we can use the Derive attribute. The syntax for the attribute is before the struct, we put a hash sign followed by square brackets, and inside of the square brackets, we can say derive, and in the brackets for the derive, we can specify the trait that we want the compiler to auto-derive for us. In this case, it is debug. This attribute syntax is similar to the one we used in our main.rs file when we wanted to disable the dead code linter. But note that for the dead code one, we put a bang after the hash. This bang means that the attribute will be applied to the item it is declared within. In this case, it is declared within the main module, so this attribute applies to the home module and all the submodules. If we don't use the bang after the hash, that means that the attribute is only applied to the expression that follows it. In this case, this is the request struct. Now the compiler will complain because it cannot implement debug for the request if the types contained in the request don't also implement debug. And we can see that it tells us that query string also needs to implement debug. So let's go ahead and sprinkle derive debug on all of our structs. We can put this on the request, but also we will need to put it on the value because it is contained in the request. And we also have to put it on the method. Now the compiler should be happy because it can auto-implement the debug trait for us. And after this change, we can go to the console and we can use cargo run to run our server. We see that the server is listening on this address. If we open a browser and we paste the address there, we will see that now the server logs the entire request to the console. So for this sample request here, the path was empty, it's just a slash, there is no query string, and the method is get. If we try to experiment a little, let's use the test path. We see that we use the path correctly. The query string is still empty. Let's add some query string. We can say that a is equal to 1. And yes, we have an implementation of our query string, and it has the key a that is a single variant that contains the string slice of 1. To better test the query strings, we can go back to our query string implementation and we can copy the example query string that we had here because it has all these weird cases with arrays and empty values. So let's see what we get after running this. Okay, so the data for our query string has the value 2 for the key B. We see that D is of type multiple and that contains a vector with all of the expected values. A is still 1, E is equal to the 2 equal signs. Remember that this is what we assign to E, and C is empty because C is just a key. It feels good to finally test our code and make sure that everything works correctly.